बोला.
Good morning, students. So today we are going to see one of the numerical problem based upon the Laplace transform under the topic that is called as the transient analysis. That this question has been asked in the examination of the D2 in the year of summer 2023. So the question is given like this: in the network of the figure, the switch is moved from position 1 to 2 at t equals to 0. The steady state condition have been established in the position 1. Determine I of t for t is greater than 0. Okay. And this is the network that will be given for this particular question. Now, in this particular network diagram, there are the two positions has been given. The first position is called as position number 1 and the second position is called as position number 2. Okay. So, whenever I want to solve such type of a problem, in that time you have to always understand what is the question is given and what you have to find out. Okay. Now the question itself mentioned that the switch is moved from position 1 to 2 at t equals to 0. So, we are starting with the solution, that is the state number 1. Now in state number 1, the switch, that is switch is moved from position 1 to 2. Moved from position 1 to 2 at t equals to 0. Right. The steady state condition have been established in the position 1. Now, one thing you have to always remember, whenever such type of words has been given inside to the question, in that case you have to understand that the steady state condition always represented the transient analysis initial condition, that is called as t equals to infinity. Got it? So, whenever I want to solve this question, I want to use this condition at t equals to infinity, which represents steady state condition. Now, this steady state condition is at a position 1. Now, it will be at a position 1. Okay. Now, the second question, now that what you have to identify or what you want to find out, you have to find out what is the current I of t that will be flowing inside this particular circuit diagram. So, we will start with the first one, that state number 1. Okay. So, state number 1. Now, the state number 1, the steady state condition have been established in the position 1. Now, the steady state condition, it means that at the switch is in a position 1 due to steady state condition, that is t equals to infinity. Now I want to solve this question by taking the condition t equals to infinity. As all of you know that in the transient analysis table there are the two conditions are given. The first condition is called as t equals to 0 plus and the second condition is called as t equals to infinity. Now I want to solve this numerical with the condition, with the initial condition t equals to infinity. Now according to the statement, I want to modify the diagram. Now this will be the new diagram. This is the position 1, this is the position 2 and this will be the another position. Now initially at a steady state condition, the switch is at a position 1. Got it? So just see the transient analysis table and you understand that there will be change in the element that will be available in the circuit diagram. Now the resistance will be as it is. The value of resistance is 1 ohm. Now in case of a inductor element at t equals to infinity, the inductor will be short circuit. So it will be short circuited. Got it? And the voltage source will be remain as it is, that is plus minus 10 volt. This will be the another element, that is resistance of 1 ohm. Got it? Now here I want to find out the value of I of t at t equals to infinity. So as this is the open circuited element, so it will be acts as a dummy. Now you have to always remember the fundamental rule state that the dummy element is always ignored whenever we are going to solve the circuit problem, the circuit solution. So the dummy element should be ignored. Now what is the value of I of t? The value of I of t equals to total voltage of the circuit, that is 10 ohm, and total resistance of the circuit, that is 1 ohm, which is nothing but equals to 10 ampere. Okay. Now this current we have identified at t equals to infinity initial condition, but this condition has been derived from this condition that t equals to 0. That's why we can return as I of 0 is nothing equals to 10 ampere. So this will be the step number 1. Now step number 2. Now step number 2. In the step number 2, we have to determine I of t for t is greater than 0 by using S domain. S domain means it's a Laplace transform domain. So for this, we have to take the first statement, that is in the network of the figure, the switch is moved from position 1 to 2 at t equals to 0. Obvious बात है, t equals to 0 plus पर t क्या होगा वो position 2 पे ही रहेगा. So we at t is greater than 0, the switch is moved from position 1 to 2. Got it? So according to this statement, we have to modify this particular circuit diagram of the network. That is, this will be your position 1, this will be your position 2, and this will be the switch position. Now at a t is greater than 0, the switch has been changing the position from 1 to 2. So right now it will be in the position 2. But this condition is not included inside the transient analysis table, so there will be no effect on the element that will be available on the circuit diagram. So 1 ohm, next is 1 Henry, the next resistance is again 1 ohm. Now here the voltage source is available, that is plus minus 10 volt, and we are connecting this circuit. Okay. So I want to find out current I of t in this particular loop. As it is an open loop, so ignore this while solving the network analysis problem. Got it? Now if I want to find out I of t inside this particular closed circuit, I want to apply KVL. So apply KVL to the above circuit. Got it? Now whenever this current I of t is passing through this resistance, the voltage drop across this particular resistance is 1 into I of t plus, now the current is passing through this inductor. Now as all of you know that whenever the current is passing through the inductor, the voltage drop across this inductor will be given as L into di by dt. So what is the value of L? L is 1 di of t upon dt. On the second, now there is no element on the lower side. Now the current is entering into this resistance. Now the voltage drop across this resistance is again I of t 1 into I of t equals to 0. So we have to simplify it. 1 multiplied with any variable or any constant will remain as it is. I of t plus di of t upon dt plus I of t equals to 0. Now I of t it is 2I of t plus di of t upon dt equals to 0. Now I want to find out I of t for t is greater than 0. But in this particular equation which we have written from this particular circuit is consisting of I of t and the derivative of I of t. So I want to solve this by using S domain. So applying Laplace transform on both sides. Okay, so the Laplace transform of I of t is 2I of s plus the Laplace transform of this derivative of I of t is s into I of s minus I of 0 equals to 0. Got it? So 2I of s, now put I of 0 equals to, now we have find out the value of I of 0 equals to 10 ampere, that is 10 ampere. Now therefore 2 into I of s plus s into I of s minus 10 equals to 0. Now taking common I of s, so it will be s plus 2. Now this 10 is a constant number, we are shifting this constant number 10 after equal to sign, it is equals to 10. So therefore I of s equals to 10 upon s plus 2. Now I don't want to find out I of s, I want to find out I of t. Now what I am doing, taking Laplace inverse transform on both sides. When we are taking Laplace inverse transform of this above equation, the Laplace inverse transform of I of s is I of t. 10 is a constant number, so we will be taking common. Now the Laplace inverse transform of 1 upon s plus 2 is nothing but equals to e to the power minus 2. So this will be the total current I of t that will be flowing across this particular
10 ampere.
So this will be the solution, final solution of I of t. Thank you so much.
थैंक यू। 10 एम्पियर निकला ना, तो क्या 10